So, what is half-life? Half-life is the time taken for the radioactivity of an isotope to fall to half of its original value. Let's let this tangerine represent an isotope with a half-life of 5 years. Every 5 years, half of the isotope will decay. This will continue until there is an unmeasurable amount of the isotope left. So how do we find the half-life of an isotope? We use the equation A equals P of 1/2 to the T over H, where A stands for the final amount, P stands for the initial amount, 1/2 is the split factor, T is the time, and H is the half-life. Now let's use this equation to find the half-life of radium-226.
The half-life of radium-226 is 1600 years. If you start out with 500 atoms of radium-226, how many will you have after 937 years? Let's plug this information into our half-life equation. The final amount stands as our unknown variable. The initial amount is 500, the T value is 937, and the H value is 1600.
Now let's see an expert's view on half-life.
So half-life is an amount of time that it takes a radioactive isotope to degrade. Okay? And so for each half-life, half of the number of molecules are reduced to another element. Okay? So if we look at, if we start with 10 atoms of carbon-14, which is a radioactive isotope, and its half-life is 5,730 years. So for every time that we come up with that amount of time, 5,730 years, the number of atoms is reduced by half. So after 5,730 years, we would have 5 carbon-14 atoms left. Okay. And that continues until there is not a measurable amount of the radioactive isotope left. And half-lives are used to determine the age of things that are really old. So we use carbon-14 a lot when we're looking at human remains or things that are within a short period of time. Different radioactive isotopes have different lengths of half-lives. Some are very long, in the hundreds of thousands of years. Some are very short.